Timber Talks is brought to you by Wood Solutions. Stay up to date with the latest in timber, the building material that is strong, safe and sustainable. Here is your host, Adam Jones.
The Pacific Timber Engineering Conference in 2019 had people from industry and academia share the latest developments in research for timber construction. I got to speak to 10 presenters at the conference, which are going to form the next 2 episodes of Timber Talks. In part 1, this episode, you're going to hear from 5 presenters at the conference, speaking on topics such as Passivhaus, sustainability, the capacity of our forests, prefabricated timber envelopes, and durability. The conversations were taken at the conference, so please excuse the little bit of ambient noise in the background. First off, we have Toby Hodsdon from Arup, who's going to introduce us to the conference and talk about the role of research for the development of timber construction.
The conference is a meeting of design professionals, practitioners and academics. And I've been really impressed over the last couple of days, partly with the standard of presentations, but their real breadth. And when you put together the practitioners who are sharing the challenges that they're facing and how they're getting over it, alongside the sometimes blue sky thinking or certainly very technically focused and detailed investigation and research work, you build up a very exciting picture of what can be possible. And by putting everyone in the same room, you allow that cross-fertilisation of ideas and then linkages of potential relationships that allow the industry to move forward.
Yeah. And what do you see as the role of research in moving us all forward?
In my keynote presentation on Wednesday, I highlighted 3 main areas that I think, 3 strands of research that makes a difference to our industry. One is trying to understand, quantify and mitigate risks, and that's by greater understanding. And that's probably what people think of initially when they think about research. But I would say that there's a step before that, which is about quantifying the benefits. And indeed, as a practitioner, I want to understand what time savings am I going to achieve by using timber? How can I have data that makes sense to architects and clients and developers that can help explain some of the broader benefits and also some of the nuances of designing and building with the material. So do we understand all of the benefits? Do we understand how we achieve them? And then on to how do we mitigate some of the risks that might be attached to it. And then the third area of research is to really explore the opportunities. Is to open up a question and perhaps take it to the limits of explore the opportunities, explore the technologies that are available to us, what are the challenges to go to that next step, where in the industry can offer that next step or step change in our in the way that we design and build. Well, one of the nice things about the timber industry is that people are willing to share and they're willing to talk about the challenges that they're facing and the solutions that they're applying. The wider construction industry would benefit from all of that, but as a field of technology and a field of human endeavour, I think we've got a great opportunity to draw on organisations like Wood Solutions, but to disseminate what we're learning and collaborate as a wider industry to really make sure that we're moving forward with the best ideas, that we're sharing best practice, and that we're avoiding and that we're sharing those lessons learned and we don't all make the same mistakes.
Yeah, sure. So my name is Marcus Strang, and I've been working at Grun Consulting, which is a specialist firm specialising in high-performance buildings, specifically the Passivhaus standard. And I've just started a PhD position at the University of Queensland, looking into high-performance buildings in subtropical and tropical climates, employing engineered wood products in the multi-storey building design, looking to replace conventional design. With conventional building materials, they don't allow any moisture to flow through. With timber, because it is such a organic material, we have a lot more flexibility with Well, I guess it's just so unique. Every climate has a unique timber product with it as well. So I'm looking at the hygrothermal behaviour of timber in tropical and subtropical climates. So that's the heat and moisture flow through the CLT and through the products. I guess trying to kind of confirm a climate-specific design for these climates, as opposed to our Eurocentric kind of design that we employ in Melbourne and probably far too much in other climates that haven't really specifically been designed for it. And I think that as we start to build more high-performance buildings, the building becomes tighter and more controlled, but then there can be an increased embodied energy associated with the more insulation and that. So using those wooden products allows us to reduce that embodied energy associated with that, and to reduce the construction industry's carbon emission. CLT is actually really well suited for Passivhaus standard, because timber itself is quite a material that has low conductivity. The cold bridge, the thermal bridging associated with the timber structure is not very high, and also if you're working with CLT panels, it's very easy to seal the envelope, and so it's quite a great material to use for high performance buildings. It's quite suited.
Hi, it's Andrea Stock here from Scion, New Zealand. Scion is the New Zealand Forestry Research Institute, and I am a sustainable architect within Scion, so I work within Scion built environment area. My activities span across the different scales of the built environment, but always thinking about the use of sustainable wood and bio-based products within the built environment. I am active in different areas of research within the built environment. One focus is in relation to the carbon storage benefit within timber buildings, which is a benefit that is known but potentially underestimated. So I am developing models to quantify the benefit of carbon storage in buildings in relation to climate change mitigation. Well, the research at Scion is funded by the New Zealand government, but we also work with private funding when we are collaborating with industry. And obviously, being a research institute, we apply for funding with research proposals that obviously we need to win. So the implication is that if we manage to develop a model to assess and calculate the benefit of storing carbon for long term in buildings, then we will be able to potentially use that quantification to assign incentives for the use of timber in construction. And this is a work that we have been doing together with Andy Buchanan from the University of Canterbury, and we are getting there. It seems promising.
When it comes to the demand of products increasing in the future, how can our forests sustain the increase in demand that might happen from the replacement of the market share of traditional materials like concrete?
So the planted forest capacity, sustainably managed planted forest capacity currently in New Zealand is showing that the capacity of the forest is to produce timber at a very fast rate, which means that the forests are capable of sustaining a growth in demand for wood in the construction sector. So depending on the growth in demand, the forest capacity is there. The whole value chain, however, needs to be able to sustain that demand when it happens, which means that the forest sector will need to integrate more with the wood product manufacturing sector, and the design and construction sector as well will need to be linked with the other sectors in order to optimize the efficiencies and the uses of the resource. Well, I like to think that my research will have a huge impact in maximizing the speed of uptake, wider uptake of wood construction in the industry. The carbon storage piece of work that I'm doing has probably the potential of demonstrating the broader and different benefits from a carbon mitigation perspective that using sustainable wood in construction has. The carbon storage, being linked to the specific project, it has the potential of being used as a mean to provide credits to the building owners for using wood, in the same way as carbon credits are provided for forest growers, or to forest growers, this is potentially an additional form of incentivization that is targeting the building owners in order to reward them for the choice of a better performing material. But we know that the challenges for achieving more sustainable development are here today, and that we are running short of time, which means that policy makers have an important role in supporting the industry and the wider community to uptake a better way of doing business and living. So I think that policy making will be a very important tool in the future in order to maximize our capacity to achieve a more sustainable future.
Welcome to Timber Talks, Eugenia Gaspari.
Yeah, sure. Thanks for having me, Adam. First of all, very happy to be here at the Pacific Timber Engineering Conference in Brisbane and to be part of this vibrant research community in general. I introduce myself shortly. I'm a lecturer at the University of Sydney in architectural technologies and building construction. So my research is in the applied design field, and in particular during my PhD and later on with Lendlease here in Australia, I designed an innovative, fully prefabricated envelope system made of timber that allows for simple, fast and scaffold-free installation. This, of course, as you can imagine, brings very many advantages to the construction process of tall buildings in terms of, first of all, time and cost savings, but also in terms of construction management and safety. And also, looking at timber buildings, the use of prefabricated enclosure would provide for immediate protection of timber structure from unfavorable weather during construction, which is a big concern in the field. On a further note, the new envelope system has been designed to be factory fitted and optimize manufacturing processes, and at the same time it is highly flexible and accommodate for different design needs. In particular, it is configurable in terms of performance to be used in various climatic contexts across Australia, and it can be used both in a load-bearing, for example, and non-load-bearing configuration, and it is compatible with a wide range of cladding systems and arrangement as well, so it can be integrated across various buildings and always look different.
How did the idea of unitised timber envelopes come about?
It started from the realization that timber skyscrapers are coming our way. In fact, the acquisition of new knowledge and experience in the field over the past decade has been gradually, I would say, pushing the boundaries of reachable height in timber construction. Now, building at height has always come along with challenges, and timber buildings are no exceptions. Safety management, for instance, is a topic of major importance when it comes to multi-story buildings, and the use of scaffold for facade accessibility is, with no doubt, among the riskiest site activities due to working at height. So in fact, I would say if we look at skyscrapers, the very majority of skyscrapers around the world, they adopt fully industrialized facade systems, unitized glass facade, to be specific, that are made of modular units that can be installed with no access, without the need to access the facade from the outside. However, these systems are often quite pricey. They are made of high impact materials, and I would say in particular they behave very poorly in terms of thermal performance. In particular, if we compare them with multi-layer opaque envelopes like timber envelopes. So this is how I had the intuition of developing a sort of a hybrid system, a unitized multi-layer timber envelopes that was able to maximize all advantages in terms of construction efficiency, but at the same time it is sustainable and guarantees excellent thermal performance.
Jeff Stringer, welcome to the podcast. Can you start by telling us a little bit about your background and what led you to your most current research?
So my background in the timber industry and timber engineering in general has really been about structural performance. So I've been heavily involved in grading and structural quality and nailed connections, but also in the durability area. So having done a lot of site inspections over my time, I was really happy to have some involvement with the Bob Lester Colin Mackenzie Design for Durability project a number of years ago, because I'm really convinced that durability is an engineering problem. It's not something to be left for wood preservationists or wood scientists. It really needs the whole risk assessment side of things done, and that really needs an engineering approach. So I've been championing that since probably I got a Gottstein Fellowship in 1993. And as a result of that, I gave the keynote presentation to the 1994 Pacific Timber Engineering Conference 25 years ago, and that was on durability. And the whole message in that talk was we need to take an engineering approach to durability. And here we are at this conference still talking about durability and the challenge that it poses. And it is a big challenge for engineers. Engineers are really comfortable with formulas and quantified material properties, but durability is a bit too fuzzy for a lot of engineers. So, but if we can develop the right methodologies and the right understandings, the right protocols, then I'm very sure that we can solve these durability problems. And importantly, that'll grow confidence in wood, and we'll start to see people accepting wood on par with other materials from a durability point of view, which is not the case now. And my real vision is just to be able to see that we can build timber buildings that are going to last 200 years, not just be happy with 50 years that the code might require, because we need to lock up carbon more than ever now, and making timber buildings last a long time is good for society, good for our customers, and morally it's the right thing to do. So I'm very passionate about durability things, and my particular topic that I'm pursuing in PhD has really been spurred on by a number of issues and things that I saw during my working career, and in particular splits in engineered wood products. That's one form of deterioration that I think's largely been ignored. It wasn't covered well in the Design for Durability project, and because it's a bit related to aesthetics and durability, conventional engineers don't really want to know too much about it. They see splits in engineered wood products as a bit of a cosmetic thing. Put the right coat of paint on and it should all be okay. But I'm at the point now where, because we're using younger and younger resource, we're getting a lot more internal stress, we're using a lot more wood in more challenging environments, we actually need some serious design methodology to make sure we get the performance that we expect. Because when we don't, it can look disastrous for timber. At this conference, I've presented some of these. I've differentiated the stresses on timber as external and internal stresses. External stresses being those applied forces that we're used to designing with as engineers, the loads on a building, etc. But then the internal stress part is really some of the residual stresses that exist in living trees that come through in our processed wood. Stresses that get into wood because of the processing, drying, etc., or bending, and other stresses And then the most important stresses I'm interested in are those stresses that exist in service, which are due to temperature and humidity variations in our atmosphere. And if they're too extreme, then we can get internal forces which are significant enough to fracture wood. And so it's that mechanism of how those fractures occur that I'm working hard to understand. And it's not rocket science, it's fairly straightforward, but the more we can understand some of the subtleties there, then that mechanism is then going to suggest some control measures.
Jeff Stringer there was talking about the importance of durability. If this is something you want to learn more about, I suggest you download Wood Solutions Technical Guide number 5, which is titled Timber Service Life Design, which is our guide for durability. In the next episode, we're going to hear from other presenters at PTEC, and we're going to go into topics such as adaptive design, connections, composite concrete timber systems, robustness, and CLT band beams. See you next time.